Okay, in this video, we're just going to go over all the questions from test number 1. So for the final, just study all the test questions. So we'll go over all those in detail, so you kind of like a video to how to do each one. Okay, so here's test 1. So with the first question, finding the distance in the midpoint between 2 points. We'll just do one of them. Let's do both pretty similar. Let's just do number 1, 1A. So what we want to do is we want to find the distance in the midpoint between these 2 points, 2, 5, and minus 1, minus 1. So let's start with the distance. So the distance between these 2 points, we have to use the distance formula. x1 minus x2 squared, y1 minus y2 squared. And so we have these 2 points. Let's just label which one's x1, y1, and which one's x2, y2. So we could just choose this one to be x1, y1, or x1, y1, and this will be x2, y2. And then we plug it into this formula, we're going to get the square root. So 2 minus a negative 1 plus, and then 5 minus a negative 1. So this is the square root of 3 squared plus 6 squared, which is the square root of 9 plus 36, which is the square root of 45. So this will be the distance between these 2 points. And for the midpoint, we have to use, so here's midpoint. The midpoint formula is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. So plugging that into this, we add up the x values, which is going to be 2 plus negative 1, so it is 2 minus 1, then divide by 2. Then add up the y values, 5 minus 1 divided by 2. So 5 plus negative 1, which is just 5 minus 1. Okay, and so this is going to be 1/2, and then 4 divided by 2, which is 2. So there's the distance, and then there's the midpoint. Okay, the next problem number 2. We have f of x is equal to 3 minus x minus 3x squared. 3 minus x minus 3x squared. And we want to find a couple of things for f of 2, f of t, and f of a plus 1. So f of 2, there's nothing really to do here. All we do is plug in 2 for x. So we're going to have 3 minus 2 minus 3 times 2 squared. So 3 minus 2 is 1. Minus 3 times 4, so minus 12, which is going to be minus 11. And then the next one, this was a. Let's put an a there. Okay, so b, that's just asking us to find f of t. And so basically all that means is, wherever we see an x now, because remember this x is just whatever we put inside these parentheses, we're going to place it here, and then we're going to place it here. So now what's on the inside of the parentheses is a t, so we're going to put a t there. So it's going to be 3 minus t minus 3t squared. So really not much to do for this part of the problem. And c, now we want to find f of a plus 1. So this is going to be 3 minus, then we plug in an a plus 1 for x, minus 3, and then plug in an a plus 1 for x again, but that one's squared. So this is going to be 3 minus a minus 1 minus 3, and then a plus 1 squared. So that's a squared plus 2a plus 1. So we get 3 minus a minus 1 minus 3a squared minus 6a minus 3. And this is going to equal minus 3a squared minus 7a. Okay, and then 3 minus 1 is 2. Minus 3 is minus 1. All right, so there's number 2. The third problem. So we want to find a line in y equals mx plus b form. So our line contains the point 1, 2 and is parallel to the line y is, 2x plus 2y is equal to 14. So we want to find the equation of a line. So what we want is this. We want y is equal to mx plus b. That's what our answer has to look like. So now we just need to figure out what m is, and we have to figure out what b is. So we know that our line contains the point 1, 2, and is parallel to the line 2x plus 2y is equal to 14. So when it's saying it's parallel, parallel means we have the same slope. So we need to figure out the slope of this line, and that's going to be the slope of this line, because our line that we're looking for is parallel to that. So the easiest way to find the slope of this line right here is to put it into y equals mx plus b form, and then the slope is just going to be that letter m, so the thing that's just attached to the x. So we have 2x plus 2y is equal to 14. So if we want to put this into y equals mx plus b, well, let's just subtract the 2x over. So we have 2y is equal to minus 2x plus 14. And we can divide everything by 2, so we get y is equal to minus x plus 7. So then we see the slope of this line is going to be minus 1. And because we have parallel slopes, our slope is going to be the same thing as this. So our m is going to be equal to minus 1. So what our line is now equal to is, we know m is minus 1, so it's just going to be minus x plus b. So now we have to figure out what b is. And in order to do that, we're going to use our point. We know our line has to contain the point 1, 2. So what we're going to do is we're going to plug this into here to find b. So here's x, here's y. So we're going to get 2 is equal to minus 1 plus b. So 2 is equal to just minus 1 plus b. Add the 1 over, we get 3 is equal to b. So now we know the equation of our line. It's going to be y is equal to minus x plus 3. All right, next problem. Problem number 4. We want to find the domain of all, let's do all 3 of these. So we're going to find the domain of the following functions. The first one is 2x squared minus x over x squared minus 9x plus 8. So when we're looking for the domain, we always think, are there fractions and are there square roots? So we don't see any square roots in this problem, but we do have a fraction. And the bottom of a fraction can't be 0. So the bottom of this fraction is x squared minus 9x plus 8. This is not allowed to equal to 0, so we have to figure out, okay, where does it equal 0? So in order to solve this equation for x, we have to factor. This is going to factor into x minus 8, x minus 1. So this can't equal 0, so x minus 8, this isn't allowed to be 0, and then x minus 1, this can't be 0. So we get x can't be equal to 8, and x can't be equal to 1. So on a number line, what we have is here is 1, here is 8. We're not allowed to be those, so we put open circles. And since this is the only issue that we had, there's no square root, so we don't have to worry about that. The only time we had a problem is when the bottom of the fraction is 0. That only happens at 1 and 8. So those are the only issues. So everything in the middle is okay. We could shade there, we could shade to the right, and we can also shade to the left. So our answer is going to be minus infinity to 1, 1 to 8, and then 8 to infinity. All right, b, we have the square root of 2x minus 10 divided by 45. So again, with domain, are there fractions and are there square roots? So in this problem, we do have a fraction, but the bottom of a fraction is just the number 45. So that's never going to be equal to 0. You know, the only time we have a problem with fractions is if the bottom is going to be 0, but the bottom of this fraction is always 45. So there's really nothing to do with that. So all we have to worry about is the square root. And when we have square roots, the inside of the square root just has to be bigger than or equal to 0. So the only thing required for this problem is x minus 10, which is the inside of our square root. This needs to be bigger than or equal to 0. So if we add the 10 over, we get 2x has to be bigger than or equal to 10. We divide by the 2, we get x has to be bigger than or equal to 5. So our only issue, here's 5, Since it's bigger than or equal to, it's going to get a closed dot. And bigger than means we're going to shade to the right. So what we have here is 5 to infinity. And then the next part, part C, we have 3x minus 9 over the square root of x plus 1. So in this problem, again, for the domain, we have to worry about fractions and square root. So we have two things. We have a fraction, and the bottom of this fraction is this, the square root of x plus 1. So the square root of x plus 1, this cannot be 0. But we also have a square root in this problem. The square root is this piece right here, and the inside of the square root is just x plus 1. So we also need this. We also need x plus 1 to be bigger than or equal to 0. So we need these two things to happen. Let's work on this left-hand side. So to solve this equation, we can just square both sides. So we get x plus 1. This can't be equal to 0. So we get x can't be equal to minus 1. Over here, we just subtract the 1. So we get x has to be bigger than or equal to minus 1. So both of these two things need to happen. So if we're on a number line, here's minus 1. This one is saying x is not allowed to be minus 1. So we put a circle on it. This one is saying it's bigger than or equal to minus 1. But since we're not allowed to be minus 1, it's basically saying this x has to be bigger than minus 1. So we're going to shade to the right. Even though this thing on the right-hand side says x is bigger than or equal to minus 1, because this one says x is not allowed to be minus 1, that means we have to get rid of minus 1. So we're only going to be bigger than minus 1. So our domain for this one will be minus 1 to infinity. Okay, the next problem, number 5. So we want to find the equation of a line in y equals mx plus b form. So our line has y-intercept equal to 4. So the y-intercept is equal to 4. And we are perpendicular to y minus 1/2 x is equal to 5. So we're looking for this, y is equal to mx plus b. We're already given that our y-intercept is equal to 4, so we know that b is equal to 4. So really what our line is this, y is equal to mx plus 4. So now we need to find our slope, but we're told that we're perpendicular to this line. So we need to find the slope of this line, and we're going to take the negative reciprocal. So the easiest way to find the slope of this line right here is just to put it into y equals mx plus b form. So we have y minus 1/2 x is equal to 5. If we just add that 1/2 x over, we're going to get y is equal to 1/2 x plus 5. So the slope of this line is equal to 1/2. But we want the perpendicular slope. So the perpendicular slope, we know it's equal to -1 divided by this slope. So -1 divided by this. Put a 1/2 down there, and this is equal to -2. So our slope that we're using for this line is going to be -2. So then the slope of our equation of our line, we know b is already equal to 4. So we have y is equal to -2x plus 4. Okay, next problem, number 6. Finding the x and the y intercepts. So we only need to do one of them. They're both the same technique. Let's do the first one. So we have f of x is equal to 6x squared minus x minus 1. So to find the x-intercept, all we need to do is set y equal to 0 and solve for x. And notice that setting y equal to 0, that's just the same thing as setting f of x equal to 0. F of x is always equal to y. So if we say y is equal to 0, that just means set f of x equal to 0. Okay, so set f of x equal to 0 and solve for x. So that means we're going to have 0 is equal to 6x squared minus x minus 1. So we need to solve this equation, but that means we need a factor. So we need to do the AC method. So we have ax squared plus bx plus c. So we have to do a times c, which is going to be 6 times minus 1, which is minus 6. And what we need to do now is figure out what multiplies up to -6, but adds up to the middle number b. The middle number is going to be -1. So we know that what that's going to be is -3 and 2. Since -3 times 2 is -6, and -3 plus 2 is -1. So in order to factor 6x squared minus x minus 1, we are going, so by using the AC method, we need to replace our middle term. So we're going to write this as 6x squared, now minus 3x plus 2x, because of these numbers right here. And then our -1, and then we have to do our grouping. We're going to group these together, group these together. So from the first two, we could take out a 3x, and we are left with a 2x minus 1. And then from the last bit, there's nothing we can take out. We just have a 2x minus 1. So now what we can do is we could factor out this 2x minus 1. And from the first term, we're just left with a 3x. And then from the last term, we're left with as 1 as the placeholder. So looking at this equation right here, we want to solve that for equal to 0. So really what we want to solve is 2x minus 1, 3x plus 1 is equal to 0. And so we have both of these pieces equal to 0. 2x minus 1 is 0. 3x plus 1 is 0. So this one on the left, we're going to get x is equal to 1/2. And this one on the right, we're going to get x is equal to minus 1/3. So both of these are our x-intercepts. So our x-intercepts, we have two of them. We have 1/2 comma 0 and minus 1/3 comma 0. Okay, so here's our x-intercepts. So now for the y-intercepts. So all we have to do for this one is set x equal to 0 and solve for y. So what is our equation? Our equation was 6x squared minus x minus 1. Let's write that down again. F of x is 6x squared minus x minus 1. So if we set x equal to 0, that's going to be 6 times 0 minus 1, which is just equal to -1. So our y-intercept is going to be the point 0 comma minus 1. Okay, number 7. So we want to, okay, let's let's just do one of these. These are both basically the same problem. So we want to find, we're given f of x is equal to 2x over 2 minus x, and g of x is equal to x over x plus 1. Let's just do, we could do part B. So part B says we want to find the domain of g composed of f of x. So let's see, what is g composed with f of x equal to? So we have g composed with f of x. This means we're taking g and we're plugging f of x inside of it. So what is g? That's x over x plus 1. And we're plugging f of x inside of it. So remember, just whatever we plug right here inside of a parentheses, we're going to place here, and we're going to place here. But now the inside of the parentheses is this f of x. So we're just going to replace all those green boxes with f of x's. So we're going to have an f of x over an f of x plus 1. What does that equal? So f of x is 2x over 2 minus x. So we're going to have 2x over 2 minus x divided by 2x over 2 minus x plus 1. And remember, when we're finding the domain of these, we don't do any simplifying. Once we replace our, in this situation, f of x with the actual definition, so here we replaced f of x with this, we find the domain and we just look at this piece right here. So there's no square roots, but we do have fractions. We have fractions in several places. There's a fraction here, there's a fraction here, or sorry, yeah, there's a fraction there, and this entire thing is a fraction. So we have three things we need to look at. Just from looking at this piece, we see that the bottom of that fraction is 2 minus x. So 2 minus x is not allowed to be 0. Same with this thing right here. That's the same piece, the same fraction. So according to that, we can't have the bottom, which is 2 minus x. So 2 minus x can't be 0. And if we were to look at this entire thing as a fraction, well, the bottom of that is this piece. So 2x over 2 minus x plus 1, this is not allowed to be 0. So from these first two, which are the same exact thing, we just get that x is not allowed to be 2. Okay, so takes care of that. So now let's look at this one on the right. This 2x over 2 minus x plus 1 can't be 0. So to solve for x here, we could subtract the 1 over. So we get 2x over 2 minus x equal to minus 1. Then we can multiply the 2 minus x over. 2x is equal to minus 1 times 2 minus x. So 2x is equal to minus 2 plus x. Subtract the x, we're going to get x. Oh, these are can't equal signs. So we subtract the x over, then we get x can't be equal to minus 2. So these are the two things that we have. X can't be 2, and x is not allowed to be minus 2. So if we go into a number line, here is minus 2, put a circle on it. Here's positive 2, we put a circle on it. And those are the only issues. So everything over here is okay. We can shade to the right, and we can also shade to the left. So we have minus infinity to minus 2, minus 2 to 2, and then 2 to infinity. All right, and so there's our domain for this problem. So the next problem on this test was, what did we just do? Number 7, so number 8. So solving inequalities, just do number A, or part A. So we have minus 3 less than or equal to 2 minus 2x, which is less than 5. So what we want to do here, let's get x alone in the middle. So we're going to subtract 2, subtract 2, subtract 2, subtract 2. So we'll have minus 5 less than or equal to minus 2x, which is less than 3. And then to get x alone, we need to divide by the minus 2's. So on the left-hand side, we'll have 5 over 2. This sign is going to change because we divided by a negative x. This sign changes again because we divided by a negative, and then minus 3 over 2. So this will be the answer for this one. And if we wanted an interval notation, so this is going to be minus 3 halves all the way up to 5 over 2. Okay, problem number 9. So we're given that f of x is equal to square root 3 minus 3x, and g of x is equal to x squared minus x minus 30. Let's just do part A. Or we can do both of these parts. So we want to find the domain of both of this. So let's find domain. Let's write that a little bit neater. So for the first one we're doing is f divided by g of x, which just means f of x divided by g of x. So f of x is the square root of 3 minus 3x, and g of x is x squared minus x minus 30. So we need to find the domain of this. So we have both square roots and fractions. So because of the square root, the inside of our square root, which is 3 minus 3x, that needs to be bigger than or equal to 0. And because we have a fraction, the bottom of our fraction is x squared minus x minus 30. We need to have that not be 0. Okay, so for this left-hand side, we can add the 3x over, divide by the 3, and we get 1 has to be bigger than or equal to x. On the right-hand side, we could factor. This could be, so we'll have x minus 6, x plus 5, yep, that's correct. And then so x can't, oh, these, yeah, x is not allowed to be positive 6, and x is not allowed to be minus 5. So let's go into our number line. We have minus 5 over here, can't be that. Here is, oh, we'll need 1 on there. And then 6, we're not allowed to be that. And this is saying it is, x has to be less than or equal to 1. So less than or equal to 1, so we put a closed dot on 1, and then we shade to the left, because x has to be less than or equal to 1. Then we stop right here. We can't shade over, or we can't hit -5, so we're going to skip that, but we're allowed to be to the left of it because this x has to be less than -1. So the only issues that we had were we're not allowed to be -5, we're not allowed to be 6, but the 6 thing actually doesn't really matter because this is saying that x has to be less than 1. So x has to be to the left of 1. So we have to skip over -5, and so whatever we have shaded, this is the domain. So our domain is going to be -∞ to -5, and then -5 to 1. All right, and then part B was, I believe, with f times g of x. So this is just equal to f of x times g of x, which is equal to the square root of 3 minus 3x times g of x, which is x squared minus x minus 30. So now we don't have any more fractions. So the only issue is our square root, and the inside of our square root is 3 minus 3x. So the only thing we really need is 3 minus 3x to be bigger than or equal to 0. So if we add 3x over, we have to have 3 is bigger than or equal to 3x. Divide by the 3, we get 1 has to be bigger than or equal to x. So the only thing we need here, here's 1, put a closed circle on it because it's bigger than or equal to, and 1 has to be bigger than x, or another way of saying that is x has to be less than or equal to 1. So over to the left. So our domain for this one is -∞ all the way up to 1. Okay, and the last question from this test, question number 10. So we want to use transformations. Use transformations to graph f of x is equal to -2 x plus 1 squared minus 3. And then we want 3 points on each graph. So we need to find our parent function. Our parent function is going to be x squared. And then the first transformation is going to be x plus 1 squared. The second is going to be -2 times x plus 1 squared. And then the third, -2 x plus 1 squared minus 3. So we start with our parent function. That is just a parabola, looks like this. And then 3 points on this graph. Well, the point 0, 0 is on the graph, the point 1, 1, and also the point -1, 1. So here's x squared. The next one, x plus 1 squared. So that plus 1 means we move everything over to the left, or we subtract 1 from all of the x values. So if we subtract 1 from the x value at the origin, we're going to have -1, 0. We subtract 1 from the point 1, 1. That's going to move over to 0, 1. Notice we're only subtracting 1 from the x values, not the y values. So this point now is going to be -2, 1. This is x plus 1 squared. And then the next graph, the -2 x plus 1 squared. So this means that we're multiplying -2 to all the y values. So this right here has a y value of 0, so that one doesn't change. We still have that point at -1, 0. This has a y value of 1. If we multiply it by -2, it now has a y value of -2. So that's going to be -2, -2. This has a y value of 1. If we multiply that by -2, that also becomes -2. So now that point is going to be 0, -2. So the graph turns upside down. And then the last one, the -3. So we have -2 x plus 1 squared minus 3. So this -3 means we subtract 3 from all of the y values. So this has a y value of 0. Subtract 3 from it. Now it has a y value of -3. This has a y value of -2. We subtract 2 from it, or sorry, if we subtract 3 from it, now it's going to be -5. And the last point over here has a y value of -2. If we subtract 3 from it, it's going to also be -5. So -2, -5. Okay, and so this graph right here, this is the graph that we were looking for.